sometimes a gene that's doing a little too well could be a problem, right? That's happening with you, by the way. I can pick on you a little bit, right? We're, yeah, there's a gene called TPH that drives the tryptophan response, right? And tryptophan is a precursor into serotonin. There's another phenomenon called epistasis. So genetics says here's what version of a gene you have. Epigenetics says here's your choices and how they affect your genes. Then there's epistasis where one gene is so powerful it affects another gene. And so that's happening with you, and it's causing two things. Your neurochemical mapping, and we can predict personality to a T. 5-year DNA, I know how you think, how you perceive, what motivates you, what you avoid, all of it, right? So your brain is experiencing an epistatic phenomenon where your tryptophan response is to some degree out overpowering your BDNF response. So BDNF is brain-derived neurotropic factor, this key fertilizer for the brain that allows you to get into what we call neuroplasticity, right? Neuroplasticity is development of the brain, making new neurons. So you do that well. This gene, you have one allele, either mom or dad gave it to you, an allele is a version, right? That causes a gene to shut off to some degree, which means when you experience something new that's sort of impactful, you go into a bit of a shell shock. It takes your brain a little bit longer to create the neurons to process the information. Some people immediately, car accident, I'm calling it Uber, right? They're just on to the next thing. For you, it's like car accident, whoa, what just happened here, right? Like freeze. Why? There's a bit of a lag time in creating those new neurons. And so for you, things mean more than they do to other people. There's more weight to stuff, right? Whether it's good news, bad news, happy, sad, you walk into something new, your reaction might be a little bit more than the people around you.